All right, another question coming in, number 10. Now, it's very important to notice something here. Notice the order or the degree of the numerator and denominator are the same. And in fact, every time we've done partial fraction decomposition, the numerator has always been smaller, and that's the case. That's what you want. So we need to fix that up real quick. Now, the quick way to do that, or not so quick way, is to do your good friend long division, right? So x cubed minus 4x, let's put it in order, minus x squared minus 4x plus 4 needs to get divided into x cubed minus 5x squared plus 16x plus 0. All right, really quickly, long division. How do you make that look like that? You multiply by 1, right? And you'd be getting x cubed minus x squared minus 4x plus 4. And then don't forget to subtract. So subtract. I like to do a sign change because it's just easier. They cancel out. This gives me negative 4x squared. This gives me 20x. And this gives me negative 4. And there it is. That's our remainder. So adding negative 4x squared plus 20x minus 4 all over. Now you're saying, hey, how did you know that was the remainder? Like, why did you stop? Why didn't you go any farther? Because I know that I can't multiply x cubed by something to get negative 4x squared. So I can't power it down any. I'd have to divide. So I'm done. And this is my new problem. Now look, the good news is the numerator is 1 less than the denominator, so I can decompose this fraction. And in fact, this kind of becomes the part that I need to compose. Now, don't forget, this blue part's still part of the answer, right? That's so far one chunk of the answer. The yellow part now is a kind of like a new problem, something that I'm going to have to solve now. So let's decompose that. So if I look at the denominator, I see it factors. I could pull out an x squared and be left with x minus 1. I see I could pull out a negative 4 and I'd be left with x minus 1. That's beautiful, right? And then I even notice, if you want, I'll put the top still up here, plus 20x plus minus 4. And now I can even factor that a little more. That's x squared minus 4, which is a quadratic. Oh, wait, it's not irreducible. It is definitely reducible. So x plus 2, x minus 2, and x minus 1. So there are all our fractions that we can decompose this into. So I have x plus 2 as one of my denominators. I have x minus 2 as one of my denominators. I don't know why I'm putting parentheses. And x minus 1 is another one of my denominators, and that's going to equal what I have on the left side. All right, so, and I'm just talking about this highlighted yellow part. Since they're all linear, I only need one variable, a, b, and c, so that's going to make this problem a little easier. And now I just got to give everybody what they're missing, right? So if you look, this guy needs the x minus 2, x minus 1. This guy needs the x plus 2, x minus 1. And this guy needs the x plus 2 and the x minus 2. So if I clean that up a little bit, I'm going to do the red parts first. If I FOIL that out, I get x squared minus 3x plus 2 plus b. If I FOIL that out, I get x squared plus x minus 2. And then the c, I would get x squared minus 4. And now finally, I will distribute the a, b, and c through and get ax squared minus 3ax plus 2a. Here I would get bx squared. And again, I'm going to use that technique of lining them up, so I think it's going to be a little easier for me, minus 2b. And then I have cx squared and minus 4c. And the only reason I do that is because, remember, I'm kind of skipping around because we've done a couple of these now. But the denominators, once I did this red stuff, the denominators were all the same and they dropped out. So now we just have numerators. And I can see what each part of the numerator is, like the x squared parts have to equal negative 4. So if you look at just the x squared parts, you know that a plus b plus c has to equal negative 4. If you look at just the x values, you know that negative 3a plus a b has to equal whatever the x's are on the left side. In this case, it was 20. And last but not least, I have x, this part here, 2a minus 2b minus 4c equals, what does it equal? Negative 4. And you could now put this into a matrix and solve, which is what I will do. And I think I will do second matrix over to edit. I think I was starting to do this. I might have had a typo though. So let's see. Yeah, I already see some mistakes on the first one, eh? So it's a 3 by 4. It's a 1, 1, 1, and it equals negative 4. Then a negative 3, a 1, and a 0 equals 20. And then a 2, a negative 2, and a negative 4 equal negative 4. Loving it. So there it is. I'm going to quit out. I'm going to RREF. And there you got your answers, right? You got A. I did it again, kids. You know, kind of remember the numbers would be nice. Negative 5, 5, and negative 4. Negative 5, 5, and negative 4. So what does that mean? Our answer to this final problem way back when we decomposed it, it is 1 plus a negative 5 for A. And what was A under? X plus 2 if I look up here at the top of the screen. And then plus a 5. And what was B under or above? X minus 2 plus a C. What was C? Negative 4. And that was over X minus 1. There you go. Now, some people, again, will throw these negatives in here and just make these negative signs. So 1 minus 5 over X plus 2, fine and dandy, right? I don't mind either way. Probably better manners. If you want to have good manners, distribute that or just move that 1 out front. That would make a lot more sense. But I want you to see where the numbers go. That's it. Stay happy.